Hi, hello. My name is Naveen. I'm from ECEB with bearing roll number 24BQ1A0496. Now I am explaining with the PDF that from the probability theory and statistic process. My first chapter is probability and a random variable. In this chapter, the probability and random variable probability through relative probability through probability through relative sets and etc. So we have to explain with the first slide. Topics. What is probability? Now I am explaining the topics of first chapter, that is what is probability and classification and definition of the probability, and the probability introduced through exams, and we have 4 exams. Now we will discuss that. Properties of the probabilities, basic problems of the probabilities. We have in our life, we have used so many ways in our life. Property for property we have to use more in companies and etc. Probability is a way that the basic probability is a way of measuring how we are likely to do something is to happen. It's a number, or is a number between 0 to 1. The probability is always lies from 0 to 1. Probability is The probability is always lies between 0 to 1. 0 means it's not an impossible event, and 1 is having a certain event. Here we have to explain a certain event means that which is exactly not assume it will happen. Definition of formal definition. The probability is a ratio of number of favorable outcomes by total number of outcomes. That is, now here we can see that probability is a ratio of number of favorable outcomes by total number of possible outcomes in a random experiment, assuming all outcomes are equally likely. See the probability, like clearly definition, we know that probability of P is equal to number of favorable outcomes by total number of outcomes. So it is an easy formula to understand. Example, when you fire a die, total outcomes is equal to 6. 1, 2, 3, 4, 5, 6. Let the event getting 4. We have different numbers in the dice. 1, 2, 3, 4, 5, 6. Now the event is to getting an 4. So the possible outcome is only 1. If we throw a die one time means we get only 1. So the probability of A is equal to number of favorable outcomes. 1 by total number of outcomes is 4. So the answer is 1 by 4. Next, probability introduced through axioms. We have 4 axioms in the probability. The axioms approach to the probability was the problem axiom was Andrei Kolmogorov in 1993 and forms the production of modern probability through 3D. It defines the probability used those set of maximum rules or axioms. In this sum of axioms, we have to follow that the probability. We can see those that key points. Sample space, yes. If we have doing an event like throwing a die or fire coin, then the number of possible outcomes are there in a sample space. The total number of outcomes present in a set is known as sample space. See the difference. The set of all possible outcomes of an experiment. The experiment is throwing a die or for throwing a coin, tossing, etc. etc. Event A subset. Even A is subset of sample space. If we said A is subset of sample space, if A has head and a sample space have head and tail, so A is subset to yes, A is subset to yes. We could as we are saying that the head is present in the sample space. A function, probability function P, a function that assumes a probability to each an event. Okay, then axiom 1. Axiom 1, probability is always non-negative. It always P of A greater than or equal to 0. Probability is always positive only. Where we are as conducting that experiment, we are conducting any experiment, the possible outcomes is always positive. It does not need to negative for an event A, that P of A here now. The probability of an event is non-negative and real number. Always real number. It does not non-real numbers. Axiom 2, normalization. Yes, normalization or certainty. P of S is equal to 1 into P of S, 1 P of S equal to 1. The probability of entire sample space is always 1. The probability is nothing but sum of the samples. Sum of the probabilities is equal to 1. That is sample space is always equal to 1. We know that sample space containing referring a die means the probability outcomes is 1, 2, 3, 4. So the sample space contains, so sum of the probabilities of the sample space is equal to 1. Exam 3. Additive if A and B are mutually exclusive. In this type we have more, let's discuss what is mutually and exclusive, what is mutually exclusive and exclusive. Mutually exclusive means they are all independent events. So A and B are mutually exclusive disjoint sets. A intersection B is equal to 5. Then we know that for P of A plus P of B into P of A union B is equal to P of AB as seen in the formula. For any infinite comfortable sequence of disjoint events A1, A2, to so on and on A1, we have P of union is equal to as shown in the formula. And next we have to discuss about the properties of the formulas. In steps we have completed in previous we completed what is probability and classic definition of the probability. The classic definition, you know that for P of A is equal to number of overall outcomes by total number of outcomes, and we discussed about the axioms that which are important for the probability. Now the third one is the properties of the probability. We already studied about the starting only the probabilities. The probability is always lies between 0 to 1. So the here first property is a 0 greater than or equal to P of A greater than or equal to the probability of event A always lies between 0 and 1. It does not above the 1, and the exactly event is always probability is equal to 1, and an impossible event is always equal to 0. So the probability of first property is always like between 0 to 1. And second property is P of A bar is equal to 1 minus P of A. P of A bar means that the event does not occur. In previous we seen about the throwing a die, and event is not getting 4. If you have event about the not getting 4 means then you are ultimately use this formula. The probability of not getting 4 is equal to 1 minus 1 by 4. Then we get the probability of not coming the 4 in the die. So this is the formula used, and this is the second property of the probability. P of A bar is equal to 1 minus P of A. And third one is P of A greater than P of B. If P A subset to B, we know that A is subset to B. If A having only 1, 2, 3 and the B have only 1, 2, 3, 4, 5, then we can say that A is subset to B. We have that B element is always present in the A element. So if an event A is subset to B, then the probability of A is equal to probability of B. Okay, you know that the important fourth property we are using a lot of P of A union B is equal to P of A plus P of B minus P of A intersection B. This is about the P of A union B means if previously we saw that the throwing a die and the event A is getting 4. Now the event, I think I want assuming that not now onwards I will take tossing at 2 points. We get a head tail head tail, and now my event is A union B is getting head 2 heads and getting has 2 tails. So we have to find out the P of A union B. Then we take P of A plus P of B minus P of A intersection B. In dice we have does not get one at a time but 2 numbers. So P of A intersection B is equal to 5. This is also called A2 law of property. For any one P of A, the formula gives the probability A or B or both occurs. That only I will say. Throwing a toss is throwing a die. We have got only one number. So 2 times 1 at a time we are not does not fit. See that. For any event A or event B, formula gives probability that either A or B or both occurs, and that's why only P of A intersection B. Next one is P of A bar intersection B is equal to P of B minus P of A intersection B. Here this is event A does not occurs by event B occurs. So in that time we have to use that formula. This is the fifth property of the probability. P of A bar intersection B bar is equal to P of B bar minus P of A intersection. This gives the probability of event B excluding the part of the lies in A. In other words, we have to see that slide. In other words, the part of B is a common with A. That's the sixth property is about the sample space containing different events. Let us assume A1, A2, A3 of the up to so on mutual exclusive events. Example, I know that you know that sum of the sample space is equal to 1 as it is sum of the probabilities of the an events is always equal to 1. Here we show that formula summation n is equal to 1 to capital A of n is equal to 1. In the sample space S, next one. So that's only. In the sample space S, compute of mutually exclusive and exhaustive A intersection B up to so on A n sum of the probabilities is 1. That only I will say that the formula summation of n is equal to P of n equal to n, P of n is equal to 1, summation probability is equal to 1. And for null sets, set of phi is equal to 0. Universal set P of S is equal to 1. In universal set, yes, we have to complete that what is a probability and classical definitions of the probability. Probabilities introduced the axioms properties of the probability. Once we remind that what is probability means probability. Probability is used in a lot of ways. Probability is then the throw sets, process, etc. Probability is number of favorable outcomes by total number of outcomes. We discussed about axioms. We discussed about the axioms and the probability interjection through if axioms are important. Here that the sample space, etc. And the properties. We discussed about the lot of properties and that's one of the properties. For the null set P of A phi is equal to 0. For the example, A intersection B, I am throwing a die. Means I will get A intersection B. I want to get 2 as well as 3 one at a time. It does not possible. So the P of A intersection B, getting 2 even does not occur. So P of A intersection for the universal S into P of S equal to 1. The null set impossible event as probability equal to 0. Yes, I want that. Startingly, I said that an impossible event of probability is always equal to 0, and the sure event is always equal to 1. For equally likely events, P of n is equal to 1 by n, I equal to 1 to so on up to etc. So we discussed about simply we are discussing now up to what is probability and classical definition of probability and probability introduced through axioms. Now the eighth one we discussed that the properties of the probabilities. We discussed the properties P of A bar B event does not occur. So P of A union B is equal to that the important formula for relating to solve the problems. And we have a lot of problems, etc. Right. So the event equally likely the probability of an event is reciprocal to the sum of the outcomes. So before you go in, so it does slide does not working. So I can explain. Before going to the problems, we have to remind that what we have to discuss. Probability is a way. First, what is probability? Probability is a way of measuring some is to be happens is always like to 0 to 1. And we discussed about the probability definition. The P of A is equal to favorable outcomes by total number of outcomes by taking an event. We have seen that throwing a die. And next one we see in probability introduced through the axioms. The first one probability introduced through axioms. Yes, we have different. We discussed about the different axiom. The first axiom is probability is always greater than equal to 0. Probability is always positive. That is, starting only. Probability is always like 0 to 1. Okay. Next, second one is normalizing or certain. Normalize. That one is norm. Normalizing or set off in the P of S sample space. And axiom 3 is additive. That P of A plus B of P of A union B is equal to P of A plus P of B plus P of A intersection B, and we different and we see different properties. The first property is properties of all probabilities always like 0 to 1, always likes between 0 to 1 for this for the for the impossible event is 0 and the certain probability is equal to 1, and the second property is P of A bar is equal to 1 minus P of A, that the event does not occur. And third property is P of A greater than or equal to P of B for A is subset to B. And the fourth property is P of A union B is equal to P of A plus P of A plus P of B minus P of A interjection B. And third property is P of A bar minus B bar. E bar is equal to P of B minus P of B minus P of A interjection B, that is gives the probability of P of A bar means A does not occur and B occurs, that gives the probability of A does not occur and B does not occur. By drawing a sample space, we can understand in a box there is a sample space and having two circles. By drawing the sample space, you can understand the probability of A. Next, the seventh one is a probability of phi is equal to 0. This is not the event does not occur. I told an example in previous. So we can enter to the problems. So the first problem is in a box contains 16 red balls, 12 black balls, and 22 green balls. See, in a box contain 12 red balls. Wait open 1 minute. Okay. Yes. In a box contain 16 red balls and 12 black balls and 22 green balls. Then what is the probability? And what is the probability of drawing a ball which is red in color, either red or black, is not green? Yes. By this problem we can cover all the properties, all the properties of the probability. Okay. Next, we can see the solution. So first we can see the solution. You know that right. In this problem they explain there is one box and containing six red with represented with an event A and 12 balls, big balls, 22 big balls is given as event B. So we can give the solution number of 1 minute. Okay, then I can clear that. Sorry for the inconvenience. And we show that number of red balls is 16. For the first, we have to see that given balls number of balls equal to 16 and number of black balls equal to 12, number of green balls equal to 22. Total number of balls we can add that all the numbers of balls 16 plus 12 is equal to 15. And we have the first one is red in color. How many are balls in red in color? 16 balls. So the first I represented as a red. So the solution I don't know, but I represented with an event A means by voice I can explain first and then we can see the solution. Okay. Red in color. How many balls in red in color? 16 balls. So the number of favorable outcomes is 16. The probability. He asked the probability. I think probability. Trying a ball red in color. So favorable outcomes is 16. A total number of outcomes means total number of balls 15. So the red in color means probability is equal to number of favorable outcomes 16 by 50. As we 16 by 50 is 0.32 by making the probability of drawing a red from the box is equal to number of favorable outcomes by total number of outcomes 16 by 50 equal to 0.32. Next bit is either red or black. Either red or black means drawing red or black. We have black and also red. So we can draw any either. See the solution. Probability of drawing either red or black. The probability of P of red or black means drawing a red ball after drawing a black ball. See the probability of drawing a wait 1 second. See the probability of P of red or drawing red red ball in the sum of the individual properties of drawing a ball and black ball. Since two events are mutually exclusive, does not happen once at a time. Here we know that we are drawing only one ball. One at a time we are drawing one at a time. We are not drawing two balls. So these are mutually exclusive events. Exclusive event. So P or B or not does not happen one at a time. So we can write it as P of red or black is equal to P of red plus P of black. First we have to drawing red balls. We in first example we can drawing red ball. Now that next second one as well as number of outcomes by total number of outcomes. How many balls of black? 12 balls. Total number of balls is 16. By calculating we can get 0.56. And third one we see the probability of drawing a black is not sorry, probability of drawing a ball that is not green. So first we have to find how many number of outcomes by green. Green means then we have to make 1 minus number of probability of so coming of green means we have found not coming of green. We know the probability of second property of the probability that P of A bar is equal to 1 minus P of A bar is equal to 1 minus P of A. That P of A not occurs means we have to find that property. So now we can say not getting green means number of favorable outcomes by total number of outcomes of the green, 22 by 15. Now the probability of drawing a ball that is not green means P of not green equal to -1. So it is 21 minus favorable outcomes. So how by solution I don't know. Wait. Number of favorable outcomes by number of balls. How many? Can you see and tell? I think right. I think so 22 balls. So the number of favorable outcomes of the green is equal to 22 by 15 total probability I can count. So not getting means 1 minus P of A intersection. So serious extraction. So we discussed in this section is what is in this section we discussed what is probability and classical definition of the properties. Classical definition of the probability is number of outcomes by total number of outcomes and probability introduced through exams. We have 3 exams. I explained that how to see that. Next properties, there are some properties I explained and as well as the properties and the above formula we have given some things. Thank you. Thank you.